We've been working with positive exponents for quite a while, and today we're going to go into negative exponents, and right along with that goes scientific notation for small numbers. So here's the major property we have to understand today to get done what we're going to need to get done. The a to the negative n equals 1 over a to the positive n. So anytime you raise a power or a number to a negative exponent, that's the same as rewriting it like this with a positive exponent. So let's see that done a few times and it'll make a lot more sense. All right, so if we're going to simplify 3 to the negative 2 power, the way we would rewrite that using that property is 1 over 3 to the positive 2 power, or 1 over 3 squared. And that's it. That's what you do every time. That's what negative exponents are. They represent very, very small numbers, numbers smaller than 1. 3 to the negative 2 is a number smaller than 1. In fact, it is 1/9. And that's how we're going to leave our answer. All right, so 2 to the negative 3 power, very, very similar here. This is going to be 1 over 2 to the positive 3 power. Okay, and then we can go ahead and simplify that and make it 1/8. So negative exponents, might seem very confusing, but there's really not much to them. We're going to make them positive and then rewrite them or simplify them. Okay, now C, 5 to the 0 power, anything raised to the 0 power is 1. That does not change. Okay. And I think example D does a good job of illustrating why anything to the 0 power is 1. Okay, because we know that when we are multiplying numbers at the same base, we add their exponents. Negative 3 plus 3 is 0. So 2 to the negative third times 2 to the third is 2 to the 0. And 2 to the 0 is 1. Let's take that a step further, though. Let me show you another way that this works out. Two to the negative third can be rewritten as 1 over 2 to the positive 3. And then we can see that 2 to the thirds cancel out. Anything divided by itself is 1. So that's why, and that's what always happens here, anything raised to the 0 power is 1 because of a situation like this, where you're dividing a number by itself. Another way to look at it, this is 3 minus 3 is 0. And that's what we do when we're dividing numbers with the same base. Okay, so let's arrange these in order from least to greatest. We've done this a lot. Now we're adding negative exponents into it. Okay, here's the first thing I'm going to look at. 2 to the negative 2 power is 1 over 2 squared, or 1/4. It's somewhere in between 0 and 1. It's not a negative number. Okay, so my smallest number is, okay, I'm sorry. And then we could look at all of these as decimals too, and I think that's what a lot of people like. 0.5 is 1/2, so 1/4 is 0.25. Obviously, our smallest number is our negative number. And then I'm going to look at this. I don't have any other negative numbers, so 0 is going to be my next number. Now I'm into my numbers that are less than 1. I see this 0.1 over here, the 0.25 and the 0.5. 0.1 is the smallest. It's kind of like a 10. 10 is smaller than 25, and 25 is smaller than 50. So there's our 0.25 is going to be next, or let's fix that though. That should actually be 1/4, right? I'm sorry, 2 to the negative 2 power is what we started off with. Then we've got our 1/2, or our 0.5, and then lastly we've got the 1, and we've got everything accomplished here. Remember that we always want to write the numbers in their original form. So even though I changed 2 to the negative 2 into 3 different forms here, I'm going to write 2 to the negative 2 in my answer. Let's find the missing exponents here. So we know that when we multiply numbers at the same base, we're supposed to add their exponents. So here we're just adding negative 3 and negative 4, so my missing exponent would be negative 7. We also know that when we subtract or divide numbers with the same power, or the base, 10 and 10, that we subtract the exponents. So 2 minus 5 here would be negative 3. All right, so let's get a little bit more abstract here, and let's get away from numbers being raised to a negative exponent, and let's deal with exponent or variables being raised to negative exponents. Okay, let's start off with my x's. I've got x to the negative third over here, and I've got x over here. Okay, negative 3, and the power on this is a 1. Okay, negative 3 plus 1, because we're multiplying, is negative 2. And then with my y's, I've got a 2 here and a negative 1 here, and we're multiplying these. So we're supposed to add the powers. 2 plus negative 1 is 1. We don't need to write that 1, so we'll just write y. Now the next step is to rewrite this expression without negative exponents. We don't want x to the negative 2. We want x to the positive 2. And we know that this is 1 over x squared. In other words, just put that x squared down on the bottom and make your negative exponent positive. And that's my final answer. That is simplified. It is simplified when we have all positive exponents and you've done all the multiplication that you can do. So we should only have one x appearing and one y appearing, and then we do. All right, so the next one. Okay. Let's rewrite this as just without division. Let's do all the division here. 3 divided by 2, or sorry, 6 divided by 2 is 3. And then I'm looking at x to the negative 2 divided by x. Now again, this power here is 1. And when we divide numbers at the same base, we want to subtract their exponents. Negative 2 minus 1 is negative 3. So we have x to the negative third power. Now again with the y, this is a 1 over here. We're going to do 3 minus 1 when we divide these is 2, so y squared. And we'll just leave the z as a negative 1. Now that's the first step. Now we want to rewrite this with all positive exponents. So this x to the negative third and this z to the negative first, I want to move those down to the bottom of this fraction. So 3y squared stays on top, x cubed on the bottom, and z to the first power on the bottom. And that is a simplified expression. There's other ways to go about this as well. I think this is the easiest way. Do all your division and then get rid of your negative exponents. And on j, we're going to write 10 to the negative fourth as a decimal number. Well, first of all, 10 to the negative fourth is 1 over 10 to the fourth. Okay, that is 1/10,000th. Okay, the 10,000th place that's the 10th place, 100th place, 1000th place, 10,000th place. Okay, and what you're going to notice here, if we look at it kind of like scientific notation, that's where we're going with this next. We kind of move the decimal place 4 spots to the left, and we'd be back at 1. 1, 2, 3, 4. Okay, we divide by 10 to the negative fourth, or 10 to the fourth, 1, 2, 3, 4. But this number is 1/10,000th. This is the 10th place, 100th place, 1000th place, 10,000th place. All right, so that leads us perfectly into scientific notation now. Scientific notation with negative exponents. We've already done it with positive exponents, which is used to represent very, very big numbers. Negative exponents are used to represent very, very small numbers. 5 times 10 to the negative fifth is actually 0.00005. Okay, and what we did is we moved the decimal place 1, 2, 3, 4, 5 places because it's negative fifth power. Okay, so 2.5 times 10 to the negative 2 would actually be 0.025. And that's it written in standard notation. Because the decimal place needs to move. It was here. Now it's 1, 2 places. to the left. So let's write these numbers that are written in standard notation in scientific notation. 0.008. That would be 8 times 10 to the negative third, because it would take moving it 1, 2, 3, the decimal place, 3 spaces to get that 8 to the left of the decimal place. And the last one. Our whole number is going to be 1.25. And how many places would we have to move that? 1, 2, 3, 4. So it's negative 4. Negative exponents are used to represent very small numbers. If lightning strikes a mile away, the sound reaches us in about 5 seconds. But its light reaches us in about 5 millionths of a second. Right? 5 millionths in scientific notation. Okay, 5 millionths as a decimal. There it is as a fraction. Okay, there's 5 millionths. A million is 10 to the 6th power. And if we move that 10 to the 6th up to the top, it would be 10 to the negative 6th. Just like you can make exponents positive by moving them from the top to the bottom, you can make them negative by moving them from the bottom to the top. Another way to look at this is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. There's your 5 millionths place. And we're going to move the decimal place 1, 2, 3, 4, 5, 6 places to the right. Last one, a nanometer is 10 to the negative 9th meters. We're going to write this number in standard form. All right, 10 to the negative 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 1 nanometer. Okay, so I showed it 2 different ways here on example O. Only showed it, just did it real quick here on example P. Negative exponents, not that much to them, just this property that we need to get down. And we'll practice this over many days. Have a great night. See you tomorrow.